Right, welcome everyone, thank you. Vladimir is a professor of computer science at UC Davis. He sits between two worlds. He has published a lot of his work in software engineering venues, and also a lot of his work in sort of health informatics, bioinformatics venues. He's been sitting between these two worlds. He has a long list of accomplishments and awards and so on. You'll find all of those in the announcement. I'm not going to repeat them. I'll just share two things that are not in the script or in the description. One is, Vladimir is one of the most creative researchers I have ever met. He has what seems to be an endless repertoire of ideas and research methods, and I think an unmatched ability to combine them in all kinds of interesting ways. So I'm very grateful for this. Second, he's probably the reason why I ended up in the US in the first place. I've known him for most of my academic career now. He's basically the one that brought me to the US as a visiting PhD student way back when. And then I was a postdoc in his lab at UC Davis. And then I ended up here and so on. So I have a lot to thank you for my trajectory. That's it. Thanks.
Thank you, Bogdan. Felt like you're talking about somebody else. Thank you, very kind. Thank you for the invite. I had a wonderful time already at dinner and yesterday, and I felt like at home. So thank you all. I've been here several times, so I know many people, and many of you know some of my work, and some of what I say will be maybe familiar, but I hope to keep you interested, even if you've seen some of my stuff. So just as an intro, so Bogdan said I work in different areas. Actually, in 2019, I decided to kind of dedicate myself to AI in health, which was, kind of luck during the pandemic that many of us were needed that have the AI ML background. And I said, I'm going to give up OSS in a year or two. I worked on open source since 2006 in software engineering, and I'm a data scientist really. So in effect, I can work in many different areas. But I find it very interesting that I can measure things, and it gives me a pleasure to do so. And so I find myself often trying to measure things that are usually unmeasurable. So we have this conversation with Jim and Bogdan and others, about qualitative and quantitative things. And, I try to measure the unmeasurable somehow, and that's why I've been in part successful. But I tried to do that in AI and health. I said, I'm going to leave OSS, and then 3 grants later, I'm still doing open source stuff. And, it seems like things are picking up again for the stuff I'm doing. So I'll be in it for a while. So yeah, I'm not giving it up. But what I want to talk to you here about is our interests have always been in understanding how programmers code effectively in spite of there being in open source more of a distributed governance and not centralized ones. And so how do people self-organize? Way back when in 2007, we started understanding that people do self-organize in open source. And we started from that, and we're still thinking about much the same things. But as I'll tell you here in our latest work over the past 4 or 5 years, we've taken it to the level of understanding the governance and not just what people do in there, and how can those two things work together. So how does the governance as the syntax, translate to operational things? Okay. So of course, interest in open source software remains to be strong. Just the current numbers show us that GitHub, one of the bigger places where open source happens, has a lot of contributions, and many of those contributions lately are, of course, about AI, right? And Python, interestingly, took over JavaScript in the last year. Copilot is being used now, so it's even easier than ever to write code, right? So 5.2 billion contributions, commits, comments, etc. More data than ever. So for many of us who analyze data, we're excited about this. And these are the top 10 open source and public projects attracting the most first-time contributors. This is all from the Octoverse report of last year. So most of these things are about AI. Okay, so that's where the interest is. So it's bringing more contributors, which is great. People are saying, AI will make us stop coding, but more and more people are coding because of AI. So this is, kind of in the silver lining. AI is bringing up a lot of new people. And yet we do know that, many of these things will not survive. Many of those new contributors to new projects, not those old ones, but new ones, many of those actually do not get to a point where they're widely available, supported, have a community. There are varying numbers for this, wildly varying numbers over the years, but about 60% of this of projects do not get to a point where they're maintained at all, right? So there's a large amount of failed projects. So that brings us to the point of, well, what do we mean by failure? What do we mean by sustainability? And so we've been throwing around this concept of sustainability just so that we could get funding and publish papers. But what does it really mean, right? In open source, people mean something, one thing. Academically, we mean something else. We can all agree in some kind of a umbrella definition. Then that what sustainability means is that you have the ecosystem or code and community should be viable over a longer term. Something a bit abstract. We actually organized an open source sustainability forum. Some of you were there in 2023 at the Internet Archive, and we polled academics, practitioners in open source, funding agencies. What do you think sustainability of open source means? And we got people to express all sorts of opinions, but most of them said that it has to do with time. There is some process that happens over time, and it's almost a trajectory. Are you on a sustainable trajectory? It's not so much an end goal as much as it is being on the right trajectory toward some sort of a success. All the people now mean different things by success versus sustainability. But it does seem that it involves several more precise things. Learning from successful examples. What have others done? Having a plan for success. Okay, very important. Reacting to downturns and adjusting trajectory. Being able to self-reflect and iterate. Right, so it's a complicated example. In fact, we can be even more precise. For one particular instance, a shining example, although a bit dated, of a foundation that we have all used the products from, the Apache Software Foundation, runs an incubator, and they have a very well-defined, albeit subjective criteria for what it means for a project, open source project, to get in the incubator and get out and be termed graduated or sustainable. And so they give projects timelines, and they give projects different milestones where there's a community. The community itself votes. Are we ready to graduate? There's mentors that vote. There's a committee that votes. Finally, there's a board that decides. So all of them inject some of their subjective opinions on what they've seen before and what they see now, and so on. So, and this will become important because we will use the ASF incubator as our starting point because it's the most precise thing we could get to. Okay, so talking about sustainability, we have to also say who cares about sustainability? Why should we care? Well, of course, academics care, but there's actually people who should care, and those are the individual OSS developers. Why waste your effort if it's not going to amount to much? So I may as well do it right. Projects themselves, ecosystems of projects, because they can learn something about all of them and impose some top-level governance. Foundations, of course, it's in their interest to have projects and guide them. And of course, companies, nonprofits, universities. Lately, OSPOs are on the rise. We are building OSPO for UC. I'm involved in that effort. So what are some of the things that OSPOs can share with nascent projects about sustainability? Local national governments are more and more involved. There's investments, and actually there's an international effort to bring open source to the fore. I went to a UN event where we were talking about sustainable open source and how a government should be involved. So for all the time we've been saying for the past 20 years that I've been involved, that open source is important, it seems like now that I'm getting too old, things are actually being recognized as important, and it's nice to be involved. Anyways, there's multi-level constituencies, possibly contrasting goals, at different levels, there may be different things, and a lot of discussion has to happen for this to be coinciding. But so how does a particular institution, in this case, Apache Software Foundation, how does it help its projects know to be on track for sustainability? So, and this is what got us started with a project that I'm going to talk about next. There's this tool, ASF Clutch. They offer this tool because it provides some useful analytics. So basically for each project, that they call them podlings while they're in their incubator, they offer these podlings, I don't know, 12 to 20 different metrics, and it's like a semaphore. So you have colors here. We're not going to talk about all the metrics, but basically, do you file timely releases? Do you file reports? Do you meet with your mentors? And so on. And you know, a project can take a look at this row and see what is in red, what is in orange, and try to attend to those. This is not longitudinal. It just stays at this point like this, and it's the same for every project. Okay, so this, of course, you know, is not satisfying because projects change, and sometimes, you know, weekly, and they may have to react to those changes on a more dynamic scale, right? And so we came up with the idea based on that clutch tool and based on the availability of a number of people that I knew across communication, governance, policy wonks from University of Massachusetts Amherst and also UC Davis. We came up with the idea that why don't we combine the stuff I've been doing before on socio-technical networks that describe and capture how projects really turn to operations and execute on stuff, combine that with the models of working with common pool resources that Elinor Ostrom put together and was researching for many years into what's known as institutional analysis and development framework. And I'll talk more about that. But the idea was, let's put all this together. We can build a new type of a theory that combines both from a structure and governance perspective, and then try to judge what the effectiveness of this open source software will be on some sort of a temporal trajectory. So we sat together in 2019, we wrote a proposal, not to the place at the NSF where you typically propose stuff with open source software, but instead to a growing convergence research. Over there, the money is bigger too. So we got this $4 million grant for 5 years to put this thing together. They were really not interested that we are doing open source. It was just a good example where we could create new theories based on convergent research. And I'll explain what convergent research meant to us and them. But basically, we're going to put all these different people together in a room and hope good things happen. That was the idea. So the idea was from foundations, Apache Software Foundation, Eclipse, etc., and finish ultimately with general GitHub projects and being able to understand what sustainability means for them. The end goals were multiple, but at least we wanted to instrument open source softwares for sustainability. Give projects the ability to monitor themselves, not just through metrics, but also actionables. An important part for the NSF to get a grant like this is to have a plan, but not a plan of work, but instead a plan of the convergence between all the areas and researchers that work together. So the plan actually involves 2 phases because the funding is in 2 phases. Only if you pass the first phase and the results are good, you go into the second phase. So most of the money is in the second phase. But the plan really had to tell what type of, so connect the work to the convergence stages. And so what we did was initially, as you can imagine, we worked in silos, okay, all separate, until finally we were able to develop language, organic collaborations, deeper collaborations, and finally to all work on tasks that are of interest to all of us with a language that we put together over the couple of years we worked together. It was a big thing. The first year we couldn't talk to each other. What sustainability means, what a project is, what a nonprofit foundation is, what a for-profit, and so on. It was very important what percentage of people in a project are working for a for-profit, in order for something to be called a nonprofit. So there was various different models and terms we had to go through. But okay, these are the outcomes that we were planning to get. Theories and tools at different levels, different outcomes. At individual developer level, being able to react to events happening in their projects. At project level, also reactions, but adjustment to governance. At the foundation level, benefit calculations, appearing fair, policy adjustments. At OSPOs, how do we build a successful OSPO and what to tell the projects that the OSPO is helping? OSPO is an open source program office, for those of you that don't know, and you have one here, and Tom is here from the local OSPO. And if you need help with open source, he is the guy to talk to. Not at this talk. Talk to me at this talk. Okay, so I'm going to tell a story in 3 parts. So the 3 parts are, part 1 is from our end, from the software engineering, socio-technical systems part, and how we worked on it to merge with the governance part, which is the second, and policy, and then third, how do we create a new theory together? Okay, so when we started off back in 2020, we thought we're going to use our socio-technical abstractions to capture the operational parts of open source software. We've been building social nets for many years, communications between developers, be it through mailing lists, be it in comments on issues. The technical nets are a different type of things. They are one half of collaboration networks. So what they are is people contributing to files. And then if you combine this, multiplied by itself, you'll get people collaborating with other people on files. Okay? So that captures 2 aspects, the social and socio-technical of this. So we first started by, of course, collecting and building big data sets. We collected everything from Apache Software Foundation Incubator. It's an interesting thing because some of those repositories were on SVN, others in Git. By putting things together, we had to deal with many different things, the aliasing, combing through mailing lists, eliminating duplicates, so on. So we built these databases, all these things are available publicly now. A very interesting data set, and I encourage you to check it out and use it. But every project in there has one of 3 labels. Either it has, 4 labels. Either it has graduated, meaning was deemed sustainable by a committee, has retired, so we can't help it, has been put, or it's still undergoing incubation. So yeah, you can check out that over there. But what we did with that data set was the following. We wanted to take the examples of graduated projects, those that have been sustainable, and learn precisely, okay, in terms of build a deep learning network, what those subjective opinions mean. So for the successful projects, unsuccessful projects, or retired and graduated, we trained an LSTM network over time, and we got predictions, and the LSTM worked really well. We actually have better models nowadays. This is back from 2021. We got greater than 90% F1 scores to predict which project very early on from the first 3 to 6 months will actually graduate at the end of the 2-3 years at the 90% or higher. The current models we have are more likely in the 95, 96% because we've learned from other foundations too, like Eclipse, OSGeo, and others. But in addition to learning, and this is what that looks like. So we fed these LSTMs, we fed general project metrics, we fed them our social and technical networks, and metrics derived from those networks. We put them through the LSTMs, and we got a thing like this, which for each month predicts a probability of, at this point, how likely you are to graduate eventually. Okay, so as you see, closer to graduation, it's either going to be close to 1 or 0. Even if you start well, over time, you may meet some challenges. This wasn't satisfying though. So sure, you build a black box model and it gives you a probability and it works well. Whoop-de-doo, right? So what do you do with this? We wanted more than this. We wanted at every given point here to know how to help these projects. Okay, oops. So in a 2024 follow-up, we actually looked at this and said, you know what, we know what our models do at this point. We know why they give you this value. Why can't we turn this into some sort of a sort of knowledge with which we can search through published literature and identify what we can do based on the variables that cause these predictions? So in other words, how can we help this project at this time? Okay, so we developed this concept of researched actionables. They're recommendations that have evidentiary support in published literature. When followed, these recommendations should yield tangible and positive results as much as anything else that has been researched and published. And I'll show you on the next page what they look like. Here, just one example. For example, we detect a downturn. It's connected to some of the features that we modeled. And because of that, we have a paper that has talked about that particular feature and how to increase it. So utilize a distributed pair programming tool that supports defined roles between the pairs. The way we did this is by using large language models that we let loose on 2,500 papers from ICSI, FSC, and other conferences and journals, top journals in the area. And we were looking for findings. We fine-tuned, and they work very well, models so that they would actually identify findings in papers that correspond to any particular feature that our model says is important. And that resulted, and so we have a tool now, it's called EvidenceBot. Not going to talk about that too much, but whatever the model is, we can take any of your variables, search for those, and then give you findings in papers that talk specifically about those variables and a positive way to increase them. You can immediately click on the reference, confirm. So we are turning something that was just a simple model and understanding into something that can potentially, to the extent that it's possible from literature, drive you to some actionables without actually going and experimenting in the field. Okay? And I can take questions anytime. Oops, I'm already halfway there. Okay. So then, with some of those things that we did, we developed a tool, which we are planning in a simplified version to also give it to our OSPO that we are just starting, a tool where you can examine, this example is for ASF projects for now, but we're going to call that tool when it goes out and released in the OSPO. It's going to be OSPEX. For now, it's just Apex for ASF. But you will see here your predictions. You will know where you are. You can look at the reacts at that given point where if there's a downturn, and you can also dig into the social networks, communications between people, and the files and all sorts of other metrics. So it's a well-functioning, extensible app. So it's something that came out as an output that we promised to do that we think may be useful for projects for self-monitoring, self-reflection. And it doesn't depend on any particular metric. So you don't choose the metrics. You just feed in, you point it to a Git repo, and it gives you a picture of this. And then you can react if you want to. But okay, let's go to the second part of this three-part story. Yes?
A quick question. You've kind of made the assumption, which we also make all the time, which is that sustainability is good with projects. It's better for a project to continue to exist and thrive than it is for it to go away. But I'm wondering if we've thought about but haven't done anything about the issue of some projects probably should die. There may be competitors that are better. And to just try to go sustain everything might not be overall, the best approach. I think it's a tough question. I just wonder if you've thought about that.
It's a very tough question. We've thought about it, and it's possible to do. But how do you publish something like that?
Carefully.
Yeah, very carefully. And then you'll have to name names as examples, right? So it's a bit difficult to think about, right? And in fact, what we have found is that those projects that don't graduate in ASFI, they don't graduate for a while. In fact, it's not just us that don't want to publish because it's difficult. The ASFI committees don't want to tell them to go. So they let them stay for an inordinate amount of time and waste resources in a way, hoping that they'll correct, yeah.
Observing these patterns and possible things to address them, do you end up with a causality model that actually provides a theory for why these things work?
Quasi-causality, and I'm going to talk about in the third part of this three-part story, yeah. So, of course, we can only do quasi-causality. Most of these are retrospective studies, right? So we are looking at data that has happened. But I have a new grant now with one of my colleagues who runs GEM5, which is a software for simulating computer architecture, like chips and such, used by AMD and others. And this GEM5 is an open source, and they've asked me, can you help us restructure our governance? We want to get from a benevolent dictator, and we discussed this with Tom, to a committee-based type of a organization. And so we agreed we're going to write this NSF grant where we're going to instrument the project, we're going to do some governance changes, and then we're going to see what happens. And then we're going to learn modeling. So that's going to be a causal, which I'm very excited about. But those are rare things. Most of our studies are retrospective. But it will be, so the most I can do, and I will show you, is quasi-causality based on, some temporal interactions. But we don't have a way to randomize things. But let's get into the governance analysis. This is most of this is done by my colleagues, and I was a part of this, but they were driving this from UMass Amherst. One of the things that they asked immediately was, hey, you have these nonprofits, and the point of a nonprofit is to serve the community, right? But often the nonprofits turn it around and serve themselves. So it would be great if you can figure out, based on the data we have, who serves whom here, or who benefits from being around. They did this study, we did this study. We took 8 ASFI documents, and they're large. We hand annotated this. It was done mostly by experts in policy and rules from communications. We identified policy and rules in all of those. We identified 233 policies. And then we annotated those policies by hand, by who it favors, ASF or the podling, the project that is being incubated. And we did this for multiple different foundations. We found that, interestingly, in ASF, it's a pretty even split. ASF and the projects, when we average over all projects there, are evenly split. So nobody's favored in these policies. So ASF is serving its community very well. And you would like to be a part of foundation. So this was a starting point. It was done by hand, but it was a starting point, and I only give this as an example of this, that we can identify policy and rules from documents. And then we took that, and of course, as I like to do, you build a pipeline for how to do this automatically and measure this and identify and measure these policies. And so we did a second study on compliance where we actually looked at the activities, not so much the policy documents, but the activities through email, so the operational stuff, if you will. And we identified different topics using some encoding deep networks. So we then clustered things based on, clustering similarities, and we did some topic modeling so that at the end, this is the result. We had the policy rules from the previous paper as identified, and then we had the email. We don't call them policies there, we call them routines, so what happens operationally. And then we semantically scored the similarities between them for each project. And so what we were asking is, how much compliance is there? Do we do what we say we should do? this is an essential step before you say, well, governance is important because we all follow governance. Well, to what extent do we comply with the governance? And so we analyzed quite a bit of emails, but you can see how we can now scale from the previous thing annotated by hand, learn from it, and do this. And we got results. So this is the stuff you can do now when you can scale this up. So we have topics organized in larger topic categories. We see here the policies and the density of those policies in different type of topics. And then we have the density in the emails. And there was no correlation. Just because there's a lot of policy about something doesn't mean people will talk that much about it. So there's the relative numbers. But what's interesting is we found that there is a correlation between the density of ASFI policy and the distribution of compliance scores. So the more policy there is, the more compliant people are, even if they're not discussing the policy. So that's an interesting finding, that people appreciate or in some ways observe more when there is more said. And I think the way we interpreted this is that if there's more policy, there has been more discussion and more people are on board, rather than the other way around, that people like rules. Okay, so that takes us to a place where we wanted to be from the start, and it's only, we're only beginning this over the past year or so. We said, well, we are really lacking theory or frameworks that can help us put all these things together. Instead of just empirically going after things, why don't we start by putting both of those together, the empirical stuff and the governance stuff in one framework? And this is not it yet. This is just IAD, the Institutional Analysis and Development by Ostrom. This was invented as a framework to investigate how actors interact with common pool resources, like cows grazing, some common grass area. Interestingly, so this involves actors. Actors are reacting to things or acting on things. They're acting in different situations that correspond to tasks. You have a context, okay? In our context, it's open source software. There's patterns of interactions, how the information flows, etc. So it's a well thought out meta, if you want, arena for doing stuff. And this most important part, the action arena, which is zoomed in here, can get pretty complex. This is supposed to, match anything you want to do, any type of science or any type of common pool resource. The important thing here is that actors are constrained by about 7 different types of rules that Elinor Ostrom came up with, and we'll see how that actually pertains to open source software in a second. The action arenas are supposed to break down a big outcome. For example, the outcome of, is a project gonna graduate? Down to simpler tasks of, are they releasing releases on time? Are they having a governance.md document, and so on. And so this actually, even before we knew about that, we had this picture of the ASFI pipeline and what happens in it. And so we have our repositories. There's all sorts of information about socio-technical governance stuff in there. And then we have projects going through the incubator, right? And some of those projects that depend on the mentors and committees' time and their own effort. By the way, that's what's going to be the common pool resource here, not the code. It's going to be the time of the mentors, the time of the committees, right? The effort put by programmers. It has nothing to do with the actual code here. So this is the action arena, and then there's decisions. One of them graduates, the other one retires. Okay, there's different things you can do after that. But that's the major outcome. Here you have smaller outcomes. Are you mentored well? Are you listening to your mentor? Bigger outcome, sustained or abandoned. And of course, this thing, the Apache Software Foundation, imposes all sorts of rules, policies, that if you compare it to a project that's going in the wild, just outside of ASF and GitHub, maybe, they're on their own. Perhaps a longer and riskier path, or maybe not. but they don't have this additional structure that's supposed to help them from above. So we put these two together. Sorry about this. The resolution is not that good, but we put these two together into some sort of a model that is still pretty vague, but lets us do things. We understand what the action situations are. We understand what the macro outcomes are. And now we can also iterate over time. Okay, and we can learn. Part of the action situation is you learn, and some of the knowledge gets passed on into the action situation. So the more things you have that are positive and negative, you can count on those. Time goes in the opposite direction because of the way it feeds back into here. So it's a framework, and now we can start asking, well, how do these actors interact with the governance? How do they interact with the ASF? We can ask all sorts of questions. And let me give you a few examples. And some of these are published, the later ones are not. One example here is we decided to see how we can put together the changes in the operational stuff in the variables we can measure in projects, like number of commits, for example, and how that corresponds to changes in governance, meaning how some rules change, how some rules are observed, complied with, not complied with, etc. To do that, we have two different things that we operationalize. One is change intervals. Those are just simply intervals, whatever feature you take, number of commits, for example. And when you say a very, very distinct, unusual edge leading down or up, we call that a change interval. You can define it more precisely with respect to, standard deviations, etc. But then you have your, more laminar kind of development. And then, of course, this is an abrupt change, a punctuated one. So you have all these change intervals. We also have something called an institutional statement. So this is more like, if you think like a generalization of the previous things that we did, the policy and rules. So here it's mostly verbs, things that prescribe, permit, advises action or outcomes for actors. Okay, this is at a sentence level, and it can include all of these three things: regulations, rules, and norms. As you can see, to do all this type of research, we needed a lot of help, not just from the governance people and understanding the IID, but also communications people. Computational linguistic, computational communications lab, we had help from there to understand what an institutional statement is and how to actually measure that. Interestingly, I'm just giving you here an example of the number of institutional statements per graduated and retired projects. And there's always kind of less guidance in the projects that did not succeed. But okay, so these are the individual things that we did, and we put them together into this quasi-causal framework. And we looked at what happens if an IS, institutional statement, the syntax somehow, if you will, is turned into operations. So we looked at ISs followed by CIs, meaning institutional statement followed by a change interval. Okay? And that's as much as we can capture because this is such a coarse level. But we did capture, so this is a 2x2 table, a positive IS. Is it followed by an interval going up or interval going down? This was for graduated projects. A negative IS. Is it associated with an interval going up or down? As we can see, most positive ISs are associated with an interval change that comes after them, up to 50% of the cases. After a positive IS from, say, a mentor, there is some change, a positive change, number of commits, amount of communication, what have you. What's interesting is between the retired and graduated, a positive IS in the retired project is much more likely to be associated with a negative, with a downturn, than with a positive change. So this is unpublished yet. No, this is published, sorry. The next thing, the more interesting one that's coming. I'm just teasing you now a little bit. But so we found that really it seems like these projects did not know how to make use of positive ISs. By the way, these ISs come from within their community, they come from mentors, they come from committees. We found no change in the presence of IS or difference between them, between graduated and retired. Those were provided at the same rate. What was different is how they were processed. Okay, almost, it's a very clear signal here that positive IS results in a negative change, which was an interesting finding. So by being able to combine governance and operations, we now can see or have the ability to see how the instructions flow through the networks and how they materialize at the end. So it's a useful framework to have. And here's the stuff that's not published, okay? So we finally built an Ostrom rule parser for the 7 rules that I mentioned. We used large language models. We can now, based on hand annotated stuff, build this parser, and it works pretty well. So we actually had to combine 2 rules into one. They were not distinguishable to the parser. They're very similar. But we have a position boundary, choice, aggregation, scope, information, and none. I'm not going to go into the details. You can ask me later. But the point is that there are different types of rules that constrain actors, and they're used at different times. So what we did was we actually went through thousands of governance.md files and processed them and found all these rules in them after we trained the thing on our annotated set. And there are many results that we have. We don't know what exactly we're going to write about at this point, but here's an interesting result, which is we analyzed project life cycles. And we knew that if you look at which rules are more present at some time, they may not all be present at another time or in the same proportion. It seems like as projects go from a nascent stage to a more middle stage and later stage, the amount, the type of rules used to enact the changes changes also. So we built profiles of rule use across the projects and then clustered the project. So we found about 3 distinct rule change trajectories, of which only 2 were enriched for sustainable projects. The other ones had only retired projects, the 3rd trajectory. So what this means is that we have a cluster of things early on. So this is the project, a life cycle, this is time, and all these things don't make any sense to you, but we have 3 clusters of similar behaviors in terms of the rules that they use and change to use. And as they switch from one period in their life to another, they use different rules. But only 2 of those correspond to successful trajectories and 1 doesn't. So there is something about how you use properly these things over your life. And we don't exactly know what makes them change, but how they use them is important, it seems, for graduation. So maybe we can capture this in a more explainable way than an LSTM that just goes through the motions and predicts. So there's a lot in this slide and a lot is hidden, so please feel free to ask questions. And while you're thinking about this, I just wanted to, I think you're right at time. So I wanted to mention my team and all the students and collaborators involved. So we had a number of postdocs and master students and of course PhD students. Some of those are very gainfully employed, some at Microsoft, like Swati, some at Google, like Dr. Yin. Mahasweta is out on the market now. Santiago is also finishing up in a year or 2. Nafis is just here for a year now. He is doing great progress. Anamika at Amherst. Curtis is now at UW. Of course, my partners in crime, Seth Frey, Brenda Bushhouse, Public Policy, Charlie in Common Pool Resources. One of the first people to, back in the 80s, write a book on success of open source software. I don't know how many of you know this, but both of these were actually students of Elinor Ostrom. And so we had almost first line of attack there. And of course, our funders, including NSF, Sloan, and Google. And I'm thank you and happy to answer questions. Yes.
So I had a question actually from the first part of your talk. You mentioned coming up with tools that can come up with actionable recommendations for projects that might be, in signs of decline or might be doing sustainability tracking. Do you know of projects that have tried using those tools? Do you have any experience or feedback from them?
Oops. So yes, we actually have not sold this properly to the Apache Software Foundation. We were trying to sell it to them. We presented it several times. We did not have. So back when we were selling it to ASF, we only had this part. So now we've developed this only last year. So now we are back in the business of showing this to people. So it's very new.
Okay.
We have local projects at UC Davis that have started using this, and they're commenting back. For them, the initial tool was too complex. Why do we need all this stuff, right? Why don't you just give us a semaphore and then we look at when it's red or whatever? And they were right. And so we're trying to simplify much of that. And then when we do that, we're gonna, the open source program office that we're building is gonna take this as one of their products that they're gonna be offering to the projects that are joining the open source program office, the OSPO we're building. And it's gonna be used across the UCs that we have. Now, the local projects that have used it, they say it's useful, but we don't look at it much, right? Some of them are too big to care. You cannot really enact change. Some of them are too small for this to be useful. And so we are trying to enlarge this by offering nascent projects a different type of style. Here are some rules to get you started without, semaphores and whatever. And for older projects, maybe pare down the actionables to something that matters to them more, like governance changes or whatever. Mm-hmm. So it still has to be made more bespoke for different types of projects. But we are working on it.
Makes sense. Thanks.
Yeah.
I'm just really curious about the trajectories. In the slide towards the end, you had 3 different trajectories. Can you say a little bit more about what they are? I mean, so for example, is there more drawing of boundaries in the successful projects over time, or?
Yeah, I'm sorry, I actually have those things, and I certainly cannot remember them because these things are very complex. But yes, that's exactly right. So we notice that as the number of people grows in projects, there is more boundary rules, right? And tasks are better defined. People have their own niches and so on.
Are those things that characterize the successful projects, but
Yes.
not the unsuccessful?
That's right. That's right. But in fact, the unsuccessful was, I believe, this thing. Both of these. So I guess the point of all this was that you can be successful in multiple different ways, right? And even some unexpected ways. The number of examples we have is still not large enough for us to be able to generalize, but it's promising. But then again, what do you get out of this? So I'm also kind of questioning, so sure, so they know this is maybe a trajectory. How do you develop such a thing organically? How do you help them as they're developing? There's still so much work to be done as to how to implement some of this in practice. Yeah.
I was interested, you were talking about the analysis you did of the emails. Is there interest in expanding to other communication networks? So like
Absolutely.
Word,
Absolutely.
groups organizing through WhatsApp?
That would be extremely interesting because we suspect it's not just a different medium, but it's a different type of communication maybe happening in the more interactive things, like if you're talking through Skype or Slack or whatever, versus emails, which take a while to respond. So we would like to be able to dig in and identify the micro actions, as well as the macro actions. So that would be fantastic. The challenge there is how do you get that data to analyze it? So we're always on the lookout. So you have any pointers? Yeah.
I just had a question about the framework that you showed, the institutional analysis and development framework.
Yes.
And I was wondering if there were,
That's Wikipedia, by the way. I forgot to put an acknowledgement.
like, when I think of governance, I think that it's, I club it with social in my mind. So I was just thinking if you had specific motivations to sort of pull that out together, and if there was a benefit to having those three specific components in the model to serve the question that you answered.
That's a very interesting point. So the way I look at it, there's governance which you prescribe, right? There's written, but there's also spoken, unwritten type of governance. And I know for a fact, all the way back to 2008 and 10, when we studied these things, a lot of emails, almost half of them, are of social nature. Yeah, got it. Okay, I'm on it, or how you doing, or whatever. And those things are actually very important to provide the glue between people so that they can continue. We talked about this a little bit. So that's an interesting thing. How much of that is actually a continuation of governance into spoken form, right? I mean, we know how by telling stories or whatever in our communities, we kind of make people also feel united and whatever. So that's well worth studying, I think. Yeah. Kind of soft governance, if you will. Yeah.
Yeah, would you say that nowadays that the participants or volunteers of open source initiative are mostly moved by the economic perspective or like actually believing in the vision? Because for example, I believe that maybe when Linux came out, or when Linus was developing Linux, there was more of a commitment towards the vision, not so much retribution, financial retribution perspective. Do you think that still stands, or mostly people moved by the economic?
I think it's a mix. The more I'm involved in the open source community, I see a lot of hardcore enthusiasts about open this, open that, open data, open government. It's becoming political, it's becoming technological, so it's a mix. But I also see that many young people are attracted for filling in resumes and showing people that they have a GitHub repo, for participating in communities, for practicing things. Lately, as we saw on the second slide, AI is very attractive. So many of the projects people get involved in is either for usage or for participating, so they can say they've done something in AI, which I think is more practically motivated rather than, ideologically. So I think it's a mix. I'm really looking forward to see where we're going to end up. I mean, usually when there's strife in society, you get good poetry, you get good art, you get all this good stuff. So I'm sure we're going to see some of the societal things reflect into also open source and the effort. So I don't know how it's going to break in a couple of years. But at this point, yes, ideology is very strong, but also there is a lot of practical interest. Sure.
So 2 questions. I'll start with the smaller skills question. So Ostrom's theory, to my understanding, primarily applies to resources that are more or less public goods, governing the commons, right? The application in this context, it seems, I wonder if you can just elaborate a little bit about how the incubator context kind of satisfies those
So within
scope conditions under which.
So within the incubator, you have a certain number of mentors, you have a certain number of committee people, you have a certain amount of hours dedicated to the people in the project, and those are the common pool resources.
Once a project enters into the incubator.
That's right.
So it's not, there is some exclusivity there.
That's right.
Entering into it.
Exactly
whereas, in Ostrom's analysis.
Exactly right. However, it's an exclusivity that is merit-based, so you can, it's not hand-selected. If you satisfy certain conditions, you can be a part of the incubator.
That sort of leads to my second question, if I may.
But there is no one-to-one correspondence. Clearly, there's more pieces here than we need, and some that are lacking. Like the temporal component is very important for us, that it wasn't that important here. But anyway, go ahead.
So the standards, or you said it's merit-based? The merit is supposedly it's defined by the incubator, right?
Right.
So it's imposing certain values and aspects out of the universe of all things that could be considered. So this could be likened to the game of Go, where Go players over the centuries have created this institution where they name strategies and develop these different play styles, but it's very much contextualized by that institution. Whereas there could be an infinite number of alternative strategies, and we've kind of seen those possibilities between AlphaGo and Lisedo, the top Go player. So similarly, could there be other merit-based criteria or other considerations that the incubator is not capturing, which could, under other circumstances, could lead some projects to be really successful in the wild?
So I think this is a great question, and I'm going to take it to a place where I have something to say about it. So we are currently analyzing about 120 different foundations to characterize the space of strategies that they have. And the idea, eventually, if we can get there, is to point projects to places that are best for them to incubate, right? So that they get the most benefit and flip that symmetric matrix to their advantage, if you will, of who benefits.
That makes sense. Thank you.
Yeah.
On your last slide, you have presented 7 different types of rules. Could you please elaborate a little bit on what the differences between these types are?
So, So position rules are, clearly, here's a position and of the actor. So actors occupy positions, right? And this is one of their constraints. So some positions have more privileges, some have less. Some have more work, others have less, right? So there's different tasks that those rules kind of confine them to and whatever. Boundary is setting up the boundaries of what you can or cannot do, right? So you're trying to access some stuff that maybe a maintainer can only access. You're not accessing. Choice of things, you can have limited choices because of where you are, right? Once you define your position. I always get confused with aggregation, so I'm gonna skip it. So scope defines, what your, actions can be. So you're doing a task, you define, the scope, just like you're defining a scope of a project, right? And again, some of these I don't want to go into without, so yeah, I'm going to skip information and aggregation, but you can look them up on the Wikipedia thing. What I do know is that they can be, even though you cannot, this was interesting, even though we couldn't find good definitions to precisely define them so we can define, well, if this, then that, still, we were able to train an LLM to capture them well based on examples, okay? Which is very interesting. Yeah, sorry for the partial answer. But you got a feeling for what they, yeah. Cool. Thank you all.
Thank you.